circular functions, which is section 4.3 in our textbook, which starts on page 355. So we'll talk about what it means to take trigonometric functions of any angle, which involves us looking at coterminal angles and reference angles. So basically what we've done so far in here is used the SOHCAHTOA, sine, cosine, tangent, and the reciprocals to find the acute angles of right triangles. But we have to think of that a lot of times in real life we might be dealing with obtuse angles as well. So to do this, we use the coordinate plane, and we call the angles that we draw on the coordinate plane, we say that they're in standard position if the vertex is at the origin, the initial side lies on the x-axis, and then we have a terminal side that's been rotated either positively, going through the coordinates in order, the quadrants in order, I mean. So this one's positive. Or negative, where we go through the quadrants in reverse order. So it's actually counterclockwise for positive, clockwise for negative. So coterminal angles have the same terminal side, but they have different measurements. There's two ways that we can get this. We can get a coterminal angle by going more than 360 in the same direction, which we see here in blue. So here's our original one in black. The original angle shown with green lettering here is 45 degrees. If I look at the blue spiral that I've just drawn and that was already there, it also has a terminal side at 45 degrees, but it's actually traveled 405 degrees. It's just that after 360, we start repeating all of the same terminal sides. We could also get there by rotating the other way around the circle, like we see here in red, where we go negative 300, that shouldn't be 75, that should be 315, negative 315 degrees. So we start now rotating the other direction, but we can end at the same terminal side. All right, so let's look at these different coterminal angles. I want to do 30 degrees. Oh, here we go. 30 degrees. So let's do both a positive and a negative version. So 30 degrees is here. So I'm going to take 30 degrees, add another full rotation to it to go all the way around. That would bring me up to 390 degrees. Or, rotating in the negative direction, I want to figure out how much less than a full rotation I went, so I can kind of do 360 minus 30 and then make it negative, or just 30 minus 360. And those are our two coterminal angles. Try negative 150 on your own. For 2 pi over 3, if we're thinking in radians, pi radians is over here. That's a little bit less than 1 pi radians, but it's greater than pi over 2. So 2 pi radians is somewhere over here. 2 pi over 3 radians, sorry. So we get one coterminal angle that's positive, where we've just wrapped around again. So I'm going to actually add 2 pi instead of thinking about 360. So that means I should change this to thirds. So then I get 8 pi over 3. And to get the negative value, rotating around this way, I'm basically going to do 2 pi over 3 minus 2 pi, which is really 6 pi over 3. So I get negative 4 pi over 3 as my negative coterminal angle. I want you to try the other one, 5 pi over 4. You can try that one on your own. A reference angle, sometimes we also refer to the reference triangle formed by it, is the angle formed by a ray and the nearest x-axis. So you can see here what a reference angle in each quadrant looks like. Always drawn with the x-axis. So just real quick, what these would look like. Oh, sorry, I have the try your own on the wrong spot. I really want you to try this one on your own. So for 30 degrees, that one's pretty easy because it's in the first quadrant. The reference angle is 30 degrees. For 5 pi over 6, again, we're less than 1 pi. So we're somewhere in the second quadrant. Our reference angle is right here. So I want to know how far from 180 or pi 5 pi over 6 is. And it's 1 pi over 6 away from the x-axis, which would be pi. Okay, so you're going to try these two on your own. That's it for coterminal reference angles and getting us started thinking about finding the trig values of angles greater than 90 degrees.